So a giddy little solar panel like this. Can I run my house from it?
No.
No? Can I drive my car from it? Why?
Not enough energy.
Not enough energy. Okay, fair enough. So, and it's quite handy because it does just look like a nice little square. So let's just draw a nice little square. Looking at it that way a bit. And let's write underneath not enough energy. Okay. Now I can't build that in multi-sim, but what can I build in multi-sim? I could put a battery in there, couldn't I? Yeah? Yeah? This will have an open circuit voltage, and we'll plug it into one in a minute and measure it on the multimeter. This will have an open circuit voltage. In other words, if you're not driving anything apart from measuring it, in this light, do you want to wire that up? Might be easy to get a multimeter from the opposite. And we'll shine your mobile phone into it in a minute, and you'll see, yahoo, it's got 3.5, 4 volts coming out. It's brilliant, the problem's solved. Well, it hasn't until you try and drive something with it. You put the motor on it, it collapses it. So it doesn't generate 4 volts when it's under load, it generates nothing when it's under load. So what we'd like to have, so I think we can make the analysis that if we say this is a battery, like this is the general form of a battery. If this battery, let's just use the number 5, if that's a 5-volt battery, okay, bear in mind we're talking in theory here now. It's great talking in theory because you can get away with everything, and it's like in Star Trek, you can go 10 times the speed of light and all the rest of it. In theory, but in practice it's slightly more difficult. So what does that mean? If I've got a 5-volt battery here, can I run my house from there? Yes, I can. Because all that battery says, and it would have this general form, if you were going into complex circuit analysis, I could drive anything with it. Why can I drive anything with it? That's silly. It's only 5 volts. But it can drive infinite current. There's no current restriction on this. I haven't said it's 5 volt 1 amp, then I'm suddenly restricting it a little bit. All I've said is that will deliver 5 volts. Well, if I put a short circuit in here, this will still drive 5 volts. Which means if you do the V equals I times R and all the rest of it, it means that there must be infinite current to be able to do that. Well, if you've got infinite current and 5 volts, power equals current times voltage. So it's 5 times infinity, that's how much power I've got. Infinite power, yeah? So, that's clearly not real. That doesn't exist in the real world. But now if I do this, and I make that 10k ohms, will that power my house? No. Why? Because the maximum current that can flow around the circuit, so when it goes round, V equals I times R. Do the sums for yourself and you'll see how much current can actually flow. Once you've got the current that can flow, you know the voltage, therefore you know the amount of power that that circuit can output. So why am I telling you this? Well, because basically the same is true here. So if we want to model a solar panel in multi-sim, all we actually do is take a battery and we can put in any value of resistor we want here. If we make this value here very small, say 1k, 500 ohms, something like that, the capacitor on here, I'm going to show you this demonstration, but never mind. the capacitor on here would charge instantly if this value here is small. If I made it 1,000,000 ohms, the capacitor would take a while to charge. That's exactly what's going on in those circuits there. We know it because we've said it. We're saving up money to buy our car. We've got the money to buy it. Saving up money to buy our next car. Buy it. And that's what happens continuously on there. So how do you model it? Put that as the solar panel. And I'll leave you to play about with this value here. But all it will do is it will shape the graph of the charge. So it might be like that if it's a sensible value, or it might look something like this if the value is too large, so it might just never actually get there. In other words, it never would take a week to charge it up because that value is too small. So what you're actually modelling by that, putting that resistor there, you're modelling how big the solar panel is, basically. Yeah. Maybe put a variable resistor in there so you can play with the values. But what it means is you can say, I've got a solar panel which is open circuit, and Shane, you're doing some measurements here, aren't you? So you've got 2.5, it's upside down, but we can look at that. Why can't I drag that? Why won't it drag? There we go, it will drag. Well, we could either turn the power supply up the other way, or let's try that. Let's think outside of the box, shall we? Oh, have a look at that, eh? Right, so we've got our solar panel there. Nothing more than connected to the multimeter there that's reading voltage. And just what I call quiescent inside this room, the background radiation, because that's what light is, it is radiation. So we've got background photons bouncing about off all the walls and everything. Our solar panel is picking up enough to convert that to 2.7 volts. It's useless because this value of resistance that we're going to model inside here is huge. 100 megaohms probably. But you see as I cover it up, look, down she goes until eventually, I mean that's just the stored capacitance on the solar panels have a certain amount of capacity. So there we are down in the millivolts range, and then all of a sudden, bang, up it comes again. Get the idea? But good question, whoever came up with that one, because it's a very obvious one that nobody usually answers. Nobody usually asks.